Okay, hi guys. We'll just check if the audio video is proper and then we will be starting with our session. So just give me 1 minute. Okay, so I guess everything is fine. And hello, welcome everyone to this amazing session of Unacademy. This is Ritika. I'm your chemistry educator, and we are here for another very important and informative session on chemistry for grade 10. So this session, it is for metallurgy. As you know, there are only 3-4 chapters which are coming, uh, I would say, which are very informative or which have many things. Otherwise, I guess every chapter in your chemistry is pretty easy in your 10th grade. And metallurgy is one of the chapter which has already many things deducted, right? So here certain topics become very important. The reason being is the whole chapter, from the whole chapter, just 50% part is going to occur in your examination, right? In metallurgy you are having only the extraction of aluminium and alloys, which are going to be your examinations part. Okay, other things are deducted. So all the very best for your preparations, and in today's class we are going to take extraction of aluminium as the main topic. Okay, now let's move ahead. Before moving forward, there is one thing, students, that I would like to tell you, that you can join us on Telegram to stay updated about all the ongoing sessions at an academy. Okay, there are different types of there are different type of classes going on at an academy, special class, plus class. So if you need the information on any of them, and if you need to join the class, you can join Telegram channel to receive all the important updates. So these are the links of your Telegram channel that you can join. Okay, so let us begin with our topic, that is extraction of aluminium. Right. Now, students, before going on, what are the extraction processes? We will be having a quick recap about aluminium. What is it? So the symbol for aluminium, it is Al, and its atomic number is 30. The electronic configuration of aluminium, it is 2, 8 and 3. That means it has got 3 electrons in its outermost shell. And since it has got 3 electrons in the outermost shell, its valency becomes 3. It donates the electrons to achieve a stable electronic configuration. The atomic mass is 27. And what is its position in the periodic table? It is present in period 3, group 3rd A. That is group 30. Okay, boron family. Now, students, this is a brief about aluminium, and aluminium is the most abundant metal which is present in the Earth's crust. Okay, and as I told you, it's very reactive, and the reactive metals, of course, cannot be found in the free states. So it is normally found in the combined states, right? And that is why the extraction process becomes a bit of tedious. Okay, this aluminium as a metal, it was discovered by Oersted in the year 1825. Now let's move on to the extraction part. So if you know, there are two main processes that we are going to study in your course right now: Hall-Herold's process. Abhi, the problem is in your examination, you can get the question in different forms. And if we do not know that what a particular process is used for, we can get confused and hence we can write wrong answers. So one process is Hall-Herold's and second is Bayer's process. Okay, we are also having another process which is not in your syllabus right now, that is refining of aluminium. Okay, now this Bayer's process, it is for purification of bauxite ore. Okay, so as I told you, there are twisted questions. First question is what is Bayer's process? Simply. Second is how is bauxite ore purified? Okay, so in two ways the questions can be asked, but the answer would remain same. So this is the first process, and the second process is Hall-Herold's. Now what happens in this process is it's the electrolytic reduction of fused alumina. Okay, now these are the two processes that you need to remember. Okay, because as I told you, the questions could be asked in any form. So first, the purification of bauxite ore happens, and then what happens is the reduction process takes place for fused alumina. Sorry. Okay, so today we will be looking for the Bayer's process first, and if the time permits, we will be moving on to the Hall-Herold's process as well. Chaliye, let's get ahead. Extraction of aluminium. Okay, so as I told you students, aluminium, it is a reactive metal. So of course it won't be found in the प्योर स्टेट, इट वुड बी फाउंड इन द कंबाइंड स्टेट, है ना. तो सबसे पहले तो हमें एल्यूमिनियम को एक्सट्रैक्ट करना है फ्रॉम इट्स मेन ओर. द मेन ओर ऑफ एल्यूमिनियम, इट इज बॉक्साइट. The formula of bauxite is Al2O3.2H2. Okay. For any mineral to be ore, what the basic need is that it should be containing a good amount of metal, and second, its extraction process must be profitable. ऐसा नहीं है extraction में हम लोग let's say 100 रुपये लगा रहे हैं और जो metal मिल रहा है it is just or 30 or 40 rupees, right? So it's a loss. Okay, तो यहाँ हमें जो bauxite है उसमें मिल जाता है 60% of alumina. That is a fair good quantity. Okay, and the other 40%, it consists of the dust, the ferric oxide, and other things which are not important to us. Okay, so for getting this alumina, we need to purify the bauxite, and this is Bayer's process is used for. Okay, so let's move on to Bayer's process. I will be telling you the different steps in which the Bayer's process takes place, है ना. तो सबसे पहले तो क्या होता है, we are taking the bauxite and we are grinding it finally. उससे क्या होगा ना, the impurities would be removed easily. Okay, so first of all, bauxite is grinded finely and heated. ओके, तो सबसे पहले जो बॉक्साइट है उसको हम फाइनली अच्छे से ग्राइंड करके उसे हीट कर देते हैं, जिससे कि क्या होता है, सारी वोलेटाइल इम्प्योरिटीज जो होती है दे गेट रिमूव. ओके, सो द मेन रीजन इज टू रिमूव volatile impurities. First point done. After that, what are we doing? We are again heating it, this time under a pressure. Okay, and with pressure we are also using some other substance. Now what is it? So it is again heated under pressure with caustic soda, that is sodium hydroxide. Okay, now this heat, it continues from 2 to 8 hours, and the temperature is approximately taken as 140 to 150 degrees Celsius, and this whole process, it is known as leaching. Okay, kindly remember the term, it is known as leaching. Okay, so what are we doing? We are taking the bauxite. Okay, we are heating it, applying the pressure, and with caustic soda solution for approximately 6 to 8 hours. Okay, the reaction that happens is Al2O3 dot 2H2O, which is our bauxite, plus NaOH, which is sodium hydroxide. It mixes to give us sodium meta-aluminate, that is NaAlO2 plus H2. Okay, balancing the equation. This is our final equation. Okay, now this product, it is known as sodium meta-aluminate. Basically what is happening, the bauxite is dissolving and providing sodium meta-aluminate. Now then here there is another term, red mud. What is red mud? So here, as you can see, the bauxite, basically it is dissolving to give us sodium meta-aluminate. Okay, and there are some of the impurities which it leaves behind. Okay, so impurities left behind the bauxite are known as red mud. Consisting of, so why is it known as red mud? Basically because of its color. The main impurity over here, it consists of ferric oxide. Okay, so consisting of ferric oxide, muds, and etc. Understood. Now this becomes our second point. Now what are we doing? We are taking that sodium meta-aluminate and we are dissolving it with water, and we are cooling that mixture. Okay, so what happens is we are diluting sodium meta-aluminate with water and we are cooling it to approximately 50 degrees Celsius. What happens is it gives aluminium hydroxide as a precipitate. Okay, what is the reaction? Let's quickly check it out. Plus H2O. Now here students, in every step you might be noticing there is a reaction, And of course, this reaction becomes a very important part of your answer. Okay, if it is asked for 1 or 2 mark or only a certain point is asked, it's well and good. But if it is asked that list all the steps, then over there your equations become a very important part. Okay, yeah. So 2H2O, it gives, what does it give? It gives sodium hydroxide and aluminium hydroxide. Now this is the precipitate that we get. Okay, understood with this step. Next step, what are we doing? We are taking this precipitate. We are first of all filtering it. We are washing it, drying it, and we are then igniting at 1000 degrees Celsius. What do we get from it? Alumina. Okay, that is AlOH whole thrice. When it is heated, the temperature range is 1000 degrees Celsius. We get Al2O3 plus 3H2O. This is our main product that we need, that is alumina. Okay, now over here we are also having this filtrate which consists of sodium hydroxide. Right now this is not a waste. Okay, this is again used for the previous processes, you know, when we were learning about the leaching process. Okay, uh, in which the bauxite was dissolved in sodium hydroxide, caustic soda. Okay, so this sodium hydroxide is again used for that particular process. Understood? So this is the basic thing, or this is the basic process of the Bayer's process. Okay, let us quickly check it out. Let's quickly revise it again. So the main ore of aluminium, it is bauxite. The formula of bauxite is Al2O3.2H2O. Bauxite, it consists of 60% of alumina and the rest are some of the impurities. Okay, so it has got a fair good amount, and that is why it is used for extracting aluminium. In the very first step, we are taking the bauxite and grinding finely. Okay, what happens due to it? When we grind finely, the surface area increases and the further processes become easier. So it's heated, and the reason for heating is all the volatile impurities, they get removed. Next, we are again heating it, this time under pressure and with caustic soda solution. The process, it is known as leaching, and this heating continues for about 2 to 8 hours at approximately 140 to 50 degree Celsius. The process, as I told you, is known as leaching. Okay, the equation that we are having in the second step is this: Al2O3.2H2, when it mixes with sodium hydroxide, it gives this as the main product. This is known as sodium metaaluminate. And there is another term, red mud. So what happens is all the impurities which are left behind the bauxite, which consist of ferric oxide, mud, sand, and all the other waste things, it is known as red mud. What do? We got sodium metaaluminate, right? Now what do we do with it? We dilute it with water and then we let it cool approximately to 50 degrees Celsius. Okay, what happens? It gives aluminium hydroxide as the precipitate. Okay, so this is shown in this particular step, as you can see. Okay, we get aluminium hydroxide as a precipitate, and sodium hydroxide is one of the side product that we get, which is of course not wasted, which is again used for the leaching processes. This precipitate, what is done, it's filtered, it is washed, it is dried, and at the last it is ignited. The temperature is as high as 1000 degrees Celsius, and what do we get from it? We get aluminum. Okay, reaction, you can see it over here, ALOH whole thrice, it gets converted to Al2O3, which is our main product. Now, this is not the final step, right? Again, this alumina, it goes for further steps which you will be learning in the Hall-Heroult process. What happens to this alumina, and how do we get the aluminium from this? Fortiger. Fortiger? Okay, what's that? Strange name. Hello. Hi. Or it's Fortiger. I don't know. Chaliye. Okay, so this was your first step. Now let's talk about what is the problem with alumina. Give me 1 second. Okay. The problem with aluminium oxide is its great affinity towards oxygen. Okay. It is a very stable compound, and that is why we cannot be using some of the easily available substances for reducing it, carbon monoxide, hydrogen, right? So it is very stable, it is having great affinity for oxygen, and that is the reason it cannot be easily reduced. Okay, so for that, for this reason, we are following the electrolytic reduction. Okay, the reason is it is not possible for some of the easily available reducing agents to reduce this to get the aluminium. Okay, now the electrolytic reduction process, it is used to obtain the pure aluminium out of alumina. Okay, now what are the problems that are or that may be faced in getting the aluminium from alumina? So from alumina to aluminium, let's discuss some of the problems that could be faced. Okay, so this electrolytic reduction, which we are going to learn in the Hall-Heroult process, this electrolytic reduction, it is possible in molten state only. Okay, so what is happening at this particular state? Okay, when the temperature is so high, when we are trying to convert it into molten state, the aluminium, it starts to vaporize. Okay, now at this point, when aluminium is also starting to vaporize, it becomes very difficult to collect the aluminium. So this is one of the difficulty that might be there when we are going to extract aluminium from alumina. Okay, all right. Now this particular difficulty, it was removed by Hall, and which we are going to learn in Hall-Heroult's process. Okay, we are going to use some of the suitable solvents. We are going to use cryolite. We are going to use some of the other important compounds so that the things become easier. Okay, now electrolytic reduction, which is also known as Hall-Heroult's process. Okay. Now, in the electrolytic reduction or the Hall-Heroult process, as we call it, there are certain important things which we are using, such as electrolytic cell, the electrolyte, etc., etc. Okay, which is a whole process to get the aluminium from alumina. So basically, this process is for alumina to aluminium. Of course, this is the topic that we will be taking in our next class, not right now. I'm just giving you a basic gist of what this process is all about. Okay, so what the basic thing or what the main thing in the extraction of aluminium is, there are two main processes. First is we are having bauxite, and from bauxite we are getting alumina. And this thing we learned right now in the Bayer's process. Okay, and next is from alumina to aluminium. Okay, this thing it happens in Hall-Heroult's process. Okay, so ये दो processes हैं which are going to be very important part of your examination. Right now, as you know, we learned about Bayer's process. In the next class, we will be learning about the Hall-Heroult's process. If there is any confusion in the Bayer's process, guys, you can ask me, and you can also join the Telegram channel to receive all the important updates about the classes that we are having at Unacademy. There are two types of classes. So special classes, they are absolutely free of cost, students. You just need to download the app, go for your grade, go for your board, and there you are for your classes. Okay, so kindly download it once and take the experience of special classes. I'm sure you will be loving it. Okay, so till the time we meet in the next class, please keep learning, keep studying, keep enjoying, and do subscribe to the channel, like and share the video if you understood the things. And let's meet in the next session. Thank you everyone. Take care.